Hello, my name is Sean Hogan. I'm a fourth grade teacher at a suburban elementary school in North Carolina, which specializes in science, technology, engineering, and math instruction, also known as STEM instruction. I've been working in the same position for the last 3 years, and I've just begun my fourth year at the same position. I teach fourth grade math and science curriculum to my own homeroom as well as an additional fourth grade classroom. And prior to working as a fourth grade teacher, I obtained a bachelor's degree in childhood education 1 through 6 and a degree in computer art from the State University of New York College at Oneonta. I'm completing my graduate program through the same university as an educational technology specialist K to 12, and I'm a strong supporter of integrating technology into the 21st century classroom. The name of my study that I will be conducting is Digital Games: The Future of Fact Fluency. In elementary school, students are expected to practice their math fact fluency in order to achieve a level of mastery in all four operations. They are expected to master multiplication and division facts by the end of third grade. Students who do not know their basic facts are at a severe disadvantage as they progress through school, as these facts are necessary for higher order math and more complicated computations. Students typically in school will do speed drills or use flashcards or practice these facts orally. As schools increasingly promote technology, though, students will have more access to math fact fluency games in the classroom and at home. Utilizing digital games can act as a supplemental resource for students to reflect on progress towards mastery with fact fluency. And this study aims to improve automaticity with fact fluency with the intention of improving student motivation and achievement when compared to traditional flashcard review methods. Today, generations of students live in a world surrounded by various technologies such as the cell phone, television, internet, video games, and touch devices. Every day, students utilize these devices to stay in touch with their community, stay up to date on current events, and to keep themselves entertained. And students are learning and communicating in ways that never existed before. They live in a world that's constantly changing and adapting to the new technologies each and every day. Students who do not know their basic math facts are at a severe disadvantage as they progress through school, but digital games have the power to change that. It is important that we promote learning through math fact fluency games in the classroom. The intent of this study is to address the educational issue of using flashcards or digital games to improve math fact fluency in two fourth grade classrooms in my school, the suburban North Carolina elementary school, for regular education fourth grade students. These research questions will guide the study. Does the use of technology for math fact fluency games impact student motivation in a fourth grade math classroom? Does the use of technology for math fact fluency games improve student achievement in a fourth grade math classroom? My research questions stem from student motivation and student achievement in math. I've noticed that over the years of my experience in teaching, student motivation and student achievement are crucial to student success in school. In math fact fluency games, utilizing digital technology and digital games is one way that could change student achievement and motivation. The research will use a quantitative research approach. I will use two different fourth grade classes, my homeroom as well as the additional fourth grade classroom, with two different learning approaches toward math fact fluency. I will interview random students in each class and compare student performance on fluency assessments in each class. One math class will utilize digital games, while the other math class will utilize physical flashcards to practice math fact fluency. On a weekly basis, both classes will be given a multiplication and division fluency check that will be timed at 1 minute for 25 questions. This quantitative sampling strategy will be used and will be probability sampling. More specifically, students will be selected as a sample from the population at random so that all students in the population have an equal chance of being selected, known as simple random. The attitude scale and pre-test and post-test instruments will be utilized for measuring, observing, and documenting the quantitative data. These will be given at the beginning of the quarter and at the end of the quarter. Throughout the quarter, half of the students will utilize digital games to practice these facts during a 10-minute station on a daily basis for 6 weeks. These students will utilize penguin jump and division derby through academics. The other half of the student sample will utilize physical flashcards to practice their facts during a 10-minute station on a daily basis for 6 weeks. The students at this station will be working independently without teacher support. Once a week, all students participating in the study will complete a mathaids.com multiplication and division assessment that will be scored and timed for progress monitoring purposes. One of the instruments used in the study to address the question regarding student motivation is an attitude scale known as the Primary School Mathematics Motivation Scale, PSMMS. A study was conducted by Ursoy and Urkus that was conducted after considering questions related to designing an ideal classroom atmosphere that encouraged self-confidence in mathematics. The purpose of that study was to develop a scale for determining motivation of primary school students towards learning mathematics. The scale was applied to 482 third and fourth grade students in Turkey. The scale itself consists of 33 items that have the intention to construct a conclusive attitude towards mathematics. There's a 3-point grading system with a maximum score from the scale of 99 and a minimum score of 33. 29 of the items are positively written, while only 4 of the items are negatively written. The 4 negatively written items are coded reversely. This was done intentionally by the authors of the scale to encourage students to thoughtfully consider each option, rather than filling out the entire column without much consideration. The scale does intend to differentiate between intrinsic and extrinsic motivation. Instead, it measures motivation of mathematics in general. In addition to the question related to improving student achievement, the students will utilize an instrument known as mathaids.com multiplication and division assessments. The purpose of these resources is to provide teachers an automatically generated assessment based on the Common Core state standards for mathematics. It's a free resource which includes an unlimited number of instant printable math assessments for use in the classroom or at home for extra practice. The assessments are intended to be used by elementary students for practice of various math topics and content. The multiplication and division drill assessments are simplistic in nature due to its design that intends to measure fact fluency and no other skills related to multiplication or division. There are 25 items on the multiplication drill and 25 items on the division drill. The drills have a time constraint of 1 minute on each drill. Teachers are encouraged to use these resources to note changes in fact fluency on a weekly or monthly basis. The 21st century society is raising up a generation of children that can be identified as digital natives. Students are going to meet the needs of these digital natives. If educators are going to meet these needs of digital natives, a different approach to learning is required to keep them engaged. Previous studies have been conducted that have already analyzed some of the benefits of utilizing digital games in the classroom. Digital games also offer additional features that physical flashcards cannot offer. For example, digital games often provide immediate feedback and track student progress automatically. The expected outcome of this study is that student achievement, regardless of whether or not students utilize physical flashcards or digital games, will improve at a similar rate. However, it is expected that a discrepancy will be observed in the motivation of students between the two classes. It is assumed that the students will utilize the digital games will have a more positive attitude towards mathematics, as well as an increased motivation in mathematics. It is anticipated that digital games will establish a more engaging environment that will help contribute to this increased motivation in mathematics.